Welcome to the course on refrigeration and air conditioning. In this lecture, we are discussing about load estimation of air conditioning systems. We have already discussed about comfort air conditioning and industrial air conditioning. In both these air conditioning systems, we have to control the temperature as well as humidity of atmospheric air. That is, either we have to increase or decrease the temperature, and we have to increase or decrease the amount of water vapor in the atmospheric air, that is the amount of moisture content. So depending upon the application, the load required or the heat has to be removed by the equipment will vary. Sometimes in domestic applications we may use a ton AC of 1 ton capacity, 1.5 ton capacity, 2 ton capacity. So this capacity is the cooling capacity of the air conditioning system. Capacity means how much heat it can remove. The rate at which heat that will be removed from the system, that is represented by the capacity. So here we are defining a term known as cooling load. Cooling load is the rate at which sensible and latent heat must be removed from the space to maintain the required dry bulb air temperature and humidity. Since we have to control the temperature as well as humidity, then if you want to reduce the temperature, you have to absorb heat from that space. If you want to reduce humidity, we have to remove moisture from that space. So how we are removing moisture? First we will convert the water vapor into liquid form, and we are removing that liquid water. So for converting water vapor into liquid, we have to absorb energy. So cooling load is the rate at which sensible and latent heat must be removed from the space to maintain the required dry bulb temperature and humidity. Suppose we have to maintain a temperature of 24 degrees Celsius inside a room, while the outside surrounding temperature is 35 degrees Celsius. We know that outside temperature is 35, inside temperature is now 24. Normally there is a chance of heat leakage from the surroundings to the room. So we have to continuously remove the heat so that we can maintain a constant temperature of 24 degrees Celsius inside the room. Similarly, for removing moisture, for reducing the humidity, we have to cool the air. When we are cooling the air, water vapor in the atmospheric air will condense into liquid, and we can remove that liquid easily. In that way, we are reducing the humidity. So, depending upon the application, the cooling load will vary. Suppose we are using the air conditioning system for cooling a room in a house. So we know that in that house, suppose it is a bedroom, there may be 3 persons or 2 persons or 3 persons will be using that room, and there will be one or two lights, and there will not be any heat producing equipment. So the cooling requirement will be very less. Now in another case, consider the case of a theater, a cinema theater, in which sometimes there may be a 500 or 600 people will be sitting inside that theater. Each person will be emitting energy. We know that human body is continuously emitting energy. So to provide comfort in an comfort in a theater, you have to use an AC of higher capacity. That is, the cooling load in that case will be greater. That air conditioning equipment should absorb a greater amount of energy compared to a domestic air conditioning system. So we know that if you want to keep a particular space at a very low temperature and low temperature and humidity, you have to absorb heat from that space continuously. Okay. Now cooling load calculations are carried out to estimate the required capacity of cooling systems which can maintain the required conditions in the conditioned space. Suppose we have to design an air conditioning system for an auditorium. And the outside conditions are that outside temperature is 35 degrees Celsius and there will be a relative humidity of 60% or 65%. Now at the inside the auditorium, you have to maintain a temperature of 24 degrees Celsius and 50% relative humidity. So that we have to reduce the temperature as well as we have to reduce the humidity. So how much heat has to be absorbed from that space in order to maintain the required conditions inside that auditorium? For that we have to do the cooling load calculations. So for estimating the required cooling capacity, one has to have the following informations regarding the design indoor and outdoor conditions, the specifications of the building, specifications of the conditioned space such as the occupancy, activity level, various appliances and equipments used. What is meant by design indoor and outdoor conditions? Design indoor conditions means what is our requirement. Suppose if you want to maintain a drivable temperature of 24 degrees Celsius, that is the design indoor condition. We need a 24 degrees Celsius temperature. What is outdoor condition? Outdoor conditions are the prevailing outdoor temperature and humidity. What is the conditions outside the room or outside the atmospheric condition? That is the outdoor condition. So we should have a clear understanding about the requirements as well as what is the existing atmospheric conditions. Next one is the specifications of the building. So specifications of the building affects a lot in the case of calculating the cooling capacity. So sometimes the building will be exposed to sunlight. So there may be 2 or 3 walls directly exposed to sunlight. In some cases there will be some windows. So sunlight will come through the window glasses. So type of surface, type of building, exposed area to the sunlight, all these factors affect the required cooling capacity. So specifications of the building is an important part. The specifications of the conditioned space. For what purpose we are using this conditioned space? Whether it is a domestic purpose or whether it is a room in a house or it is an auditorium or it is a conference hall or it is a cinema theater. Then what is if it is an auditorium, what will be the occupancy? Whether it is meant for 50 persons, 100 persons or 150 persons or 1000 persons. Activity level. Activity level means, so suppose if a person is sitting inside a room without doing any activity, he will emit very less amount of energy. If the person is doing some exercise, he will emit a lot of energy in the form of heat. So that heat has to be removed. That is activity level. And various appliances and equipments. So if you are using some electric motor, that electric motor will emit heat. So that heat has to also to be removed. So some electrical equipments, if you are operating inside a space, that will cause heat generation. Then that heat also has to be removed. So these 3 parameters has to be known before estimating the required cooling capacity. So for comfort applications, for comfort air conditioning, our aim is the cooling capacity is decided by considering the thermal comfort. For comfort applications, the required indoor conditions are fixed by the criterion of thermal comfort. Thermal comfort means comfort of human beings. While for industrial or commercial applications, the indoor conditions will vary depending upon the process that is carried out in that space. For example, if you are using an industrial air conditioning system for storing milk, processed milk, so there will be a certain standard for storing milk which has to be stored at a particular temperature. So if you are using an industrial air conditioning system for using leather industry or textile industry, the requirement may vary. But for in comfort air conditioning system, the requirement will be same in all the areas because it is only based on the thermal comfort of human beings. But industrial air conditioning, depending on the type of industry and type of process, the required indoor conditions will vary. because for different process and different industries the requirement is different. Now, how we can calculate the total cooling load? That means how we can calculate how much heat has to be removed from a particular space. Now consider the case of a room or a building. The building consists of walls, roof, floors, windows, doors, etc. So the outside temperature is high. The inside temperature has to be kept at a very low point, a very low temperature. So there may be heat leakage from the outside to the inside. So total building cooling load consists of heat transferred through the building envelope. That heat will transfer through the walls, it will transfer through the roof, floor, windows, doors, etc. And this is the heat coming from outside. And inside the building, there will be occupants, equipments, lights, machines, etc. So the total building cooling load consists of heat transferred through the building envelope and heat generated by occupants, equipment and lights. So the load due to heat transfer through the envelope is called external load, while all other loads are called as internal loads. So you can see this figure. So it shows a house. Now, so this is inside area we have to keep it a comfort condition. It's at a very low temperature. And inside we have occupants is there. Here in this figure they are using a laptop, and there will be some other applications. There will be light, inside light. So there will be heat leakage from the surroundings to the room, and there will be heat generation from inside itself. So the humans are emitting heat, the equipments are emitting heat, there is a light, the light is emitting some amount of heat. So these are internal sources, and whatever the amount of heat coming from the outside is known as external source of heat. So we can define what is meant by an external load and internal load. The load due to heat transfer through the envelope. Envelope means the walls, roof, floor, windows and doors is called external load, while all other loads are called as internal loads. Now the total cooling load on any building consists of both sensible as well as latent load components. So what is meant by the sensible load and latent load? Sensible load means, consider we have to calculate the cooling load requirement of an air conditioning system that is used in a home. Now consider this figure. So this is a house. We have to calculate the cooling load requirement of this house. So there is sunlight is falling on the roof as well as walls. Sunlight is passing through the windows. So we know that there is a increase in temperature, drivable temperature of air due to this heat transfer. So there is heat is transferring from the surroundings to the room, as well as heat is generated inside the room. So we have to reduce that temperature. So reducing that temperature, that how much amount of energy has to be absorbed for keeping the inside space at the required temperature. That is known as sensible load. That is when we are absorbing heat, the temperature is reducing. That is known as sensible cooling. That falls in sensible load category. Then next one is latent heat load. Latent heat load means, suppose this is an air conditioned room. There are a lot of occupants there. So what happens, after some time the moisture content inside this room will increase. So how the moisture content is increasing? Because the occupants are inhaling and exhaling air. During exhaling, water vapor is coming outside, as well as for providing required fresh air to the room, we have to supply some outside air into the room. So along with the outside air, some water vapor is entering into the room. So this will cause the amount of moisture content inside the room to increase. So when the amount of moisture content inside the room exceeds our desired value, we have to reduce that moisture. So how we are reducing that moisture? We have to convert that moisture into liquid by cooling the air, and we have to remove that moisture. So that accounts the latent load. So amount of energy absorbed for removing the moisture is known as latent heat. So there will be both sensible load as well as latent load. The sensible load affects drivable temperature, while the latent load affects the moisture content of the conditioned space. So due to the heat coming from outside, the drivable temperature increases. Due to ventilation, due to the supply of fresh air into the room, the latent load will increase. So these sensible load as well as latent load has to be removed with the help of the air conditioning system. Now total cooling load on a building can be classified into external load and internal load. So external load is the load coming from the outside. So it includes heat transfer by conduction through the building walls, roof, floor, doors, etc. Heat transfer by radiation through the fenestration such as windows and skylights. Fenestration means windows. Sometimes there will be glass windows, and skylights. Skylights are used for allowing sunlight to enter into the room. In some areas, we provide glass in the roof, top roof, for daylighting, for utilizing the solar energy for lighting the inside part of our room. So there will be heat transfer through the building walls, roof, floors, doors, and there will be heat transfer by radiation through windows as well as skylights. This is one part. So outside we have higher temperature. So if there is a temperature difference, there will be heat transfer from the high temperature area to the low temperature area. So the outside temperature will be high. The heat will transfer through the building walls, roof, floors, doors, and we know that the sunlight is falling on our building walls and roof. So when the sunlight falls on the building walls and roof, the walls and roofs will get heated up, and this will start radiating. So that radiative heat is also coming inside the room. When the temperature of walls and roofs increases, it will start to emit radiative heat. So due to that radiation, the inside temperature of the room will increase. And sometimes we are using glass windows. So when the solar radiation comes directly through the glass windows and falls inside the room, that will also cause external load. That will also help to increase the temperature of air inside the room. Another one is heat transfer due to infiltration. Infiltration means the leakage of air into the room. So there is a chance that some amount of air will leak to the room from the surrounding. Sometimes in the case of a room, we may open the door and we may open and close the doors. So when we are open the door, some air will come inside. That's the infiltration air leakage. So the outside air is at a higher temperature. When it is entering into the room, that temperature has to be removed or reduced. So that is an external load. Then the outside air is having high moisture content. So when that outside air is entering into our room due to infiltration, the moisture content of our room air will increase. That has also to be removed. So heat transfer due to infiltration consists of both sensible as well as latent components. So next is the internal load. The total cooling load on any air conditioning system can be classified into external load as well as internal load. Internal load is a sensible and latent heat transfer due to equipments, products, processes, and appliances. and sensible heat transfer due to lighting and other equipment. So internal load is the cooling demand or cooling load that is generated inside the room or inside the space that has to be air conditioned. So there will be some occupants in the case of a domestic air conditioning system as well as air conditioning system for theaters, auditoriums, seminar halls, hospitals. There will be occupants. So we know that every individual or a person, a human being is like a heat generating machine. So we are continuously emitting heat. So if the amount of occupants are or the number of occupants are more, there will be more heat generation inside that room. So that heat has to be removed. As well as products, if there is a high temp, some products are at a high temperature, that has to be cooled. And process and appliances. Process means if you are using the air conditioning system for an industrial purpose, there will be some chemical reactions, and due to this chemical reaction there may be some release of energy, heat energy. That heat energy has to be removed. So during some process there will be some release of moisture, so that moisture has to be removed. And so in some applications we have to keep the temperature and moisture at a particular level for the chemical reaction to take place. So that industrial application processes and equipments affect the internal load. Then the lighting is another part. So we are using lights for lighting purpose, and we are using LED lights, CFL lights, and in older times we are using incandescent lamps. So incandescent lamps emit high amount of energy. Whatever the power rating, that power rating is completely converted as heat energy. And other types of lights also emits energy. So if you are using some electric motor inside a room, that electric motor will emit heat. That also will fall in internal load. So it is due to occupants, products, process and appliances. This internal load is coming. Now this way is already discussed. This illustrates the case of a air conditioning of a home. So there are some occupants inside this room, and there are some appliances. There is a laptop, or there will be some lighting. Due to this lighting and appliances and occupants, there will be internal load, and there is an infiltration, leakage of air into the room. This is a solar radiation through glasses and windows, solar radiation through opaque surface. Opaque surface means the building roof which is not transparent to sunlight. Sunlight will not transmit through these building walls, but when the sunlight falls on the roof and walls, the roof and walls will get heated up. So there will be heat transfer in the mode of conduction as well as heat transfer by mode of radiation. So that will cause the external load to the room, and the appliances, occupants and lighting will cause internal load to the cooling system, and combining all these load, the total cooling load can be determined. Next, we can discuss how we can estimate the external loads in an air conditioning system. So estimation of external load, first is the heat transfer through opaque surface. Opaque surface means a surface which is not transparent. So when the solar energy falls on a wall or a roof, what will happen? Due to solar energy, the temperature of the wall and roof will increase. So there is a chance that the heat energy will transfer from the outside to the inside of the room by conduction as well as by radiation. So when the temperature increases, the roof and walls will start emitting radiation. So this will cause an increase in the dry bulb temperature of air inside the room. So first component of external load is heat transfer through the opaque surface. Second one is heat transfer through fenestration. Fenestration means the transparent windows and skylights are known as fenestration. So if our window is made up of glass, if it's a glass window, when the solar radiation falls on that glass window, it's a transparent to solar radiation. It will allow solar radiations to pass into the room. So these solar radiations directly heat up the air inside the room. So automatically the arrival temperature increases due to this solar radiation. Another one is heat transfer due to infiltration. Infiltration is the leakage air coming inside the room. So the outside air temperature will be high. Suppose we are keeping the air inside our room at 24 degrees Celsius while the ambient temperature is 35 degrees Celsius. When there is an infiltration of air at 35 degrees Celsius is entering into the room. That will cause the dry bulb temperature of inside air to increase. So when air at 35 degrees Celsius enters and mixes with the air at 24 degrees Celsius, there will be an increase in dry bulb temperature, and that is a cause of external load. In addition to that, the infiltration air also has some latent load. What is this latent load? The outside humidity level will be different. So when the infiltration air is entering into the room, it changes the humidity level at the room. Another external load includes we are using some supply ducts for transferring the conditioned air to the room, as well as for returning the air from the room to the conditioning space. Consider the case of a centralized air conditioning system. In a centralized air conditioning system, we are treating the air at a particular location and we are supplying that air with the help of fans through some supply ducts. And from the room, we are absorbing the air through return ducts, and the return ducts will go to the air conditioning plant, and that air will be again conditioned. So through the supply duct as well as return duct, when the air is flowing to the supply duct as well as return duct, there will be heat transfer from the surroundings. So that heat transfer is also has to be considered. And for supplying air as well as for absorbing air from the space, we are using supply air fan as well as return air fan. So these two fans are working with the help of motor. So when the motor is operating, there will be some heat release. That also has to be considered while calculating the external loads. So other than solar radiations and infiltration load, there are some other miscellaneous external loads. It includes the load due to ventilation air. So we have to provide fresh air supply to the room. For that, we are always supplying some fresh air from the atmosphere. So we have to reduce the temperature and humidity level of that fresh air. That is a external load. Then sensible and latent heat due to the air leakage in the supply ducts and return ducts, as well as the heat load associated with the working of supply air fan motor and return air fan motor. Next, the internal load. Internal load consists of load due to occupants, load due to lighting, due to equipment and appliances, and due to product stored or process being performed in the conditioned space. So first one is a load due to equipments. So a person, when he is idly sitting, is also emitting some amount of energy. So it consists of two types of load, both sensible as well as latent load. Sensible load means when the person is emitting energy, the air temperature will gradually increase. Because the number of equipments are more, after some times the air temperature will increase, the dry bulb temperature of air will increase. As well as there is some latent heat component. From where the latent heat component arises? When we are exhaling that air will contain some moisture content, as well as when we are sweating, that sweat will evaporate and that will add moisture in the air. So the radiation or heat energy radiated by our body will cause sensible load, and the amount of moisture coming out from our body will cause latent load. So the rate at which the sensible and latent heat transfer takes place depends mainly on the population, the number of occupants and activity level of the occupants. If all the occupants are sitting idle, if there is no activity, there will not be the limited amount of energy emission. And if consider the case of a gym, where all the occupants are actively involved in some exercises, they will emit high amount of energy, and the amount of latent as well as sensible heat load will be more. Another one is load due to lighting. The lighting systems used for domestic as well as industrial purpose will cause sensible heat transfer to the conditioned space, both in the ways of radiation as well as convection. Also, the equipments and appliances, some motors used in the conditioned space may add both sensible as well as latent loads to the conditioned space. Suppose we are ironing, we are using some electric iron that will emit heat. Suppose we are using a fan, that fan will be emit heat, the motor of the fan will emit heat. If you are using some another equipments like mixie or grinder, anything, that will also emit heat. All the electrical appliances will emit some amount of heat, so that will add to the load due to equipments. And if the conditioned space is used for storing products, then example cold storage or for carrying out certain process, then these sensible and latent heat released by these specific products and process must be added to the internal cooling loads. Suppose we have a cold storage. That cold storage is used for storing milk at 10 degrees Celsius. Now, if suddenly a new bulk packets of milk at 25 degrees Celsius is, now we are bringing 25 milk at 25 degrees Celsius into this cold storage. So that has to be removed. That milk, the temperature of the milk has to be reduced to 10 degrees Celsius. That is the cooling load. Next, we are determining how we can estimate the cooling capacity of the system. So, since the last few slides, we have discussed about the cooling load acting on the room. Now, how we can find the cooling capacity of the system? So, for cooling capacity of the system is cooling capacity of the equipment, the air conditioning equipment. So, there are some more factors which has to be considered before finding the cooling capacity of the system. That is, we have to consider the sensible and latent heat loads due to ventilation and leakage loss in the return air ducts and heat added to the return air fan. So consider this room. This is the air conditioned room. Ti is the inside dipole temperature. Wi is the inside specific humidity. Hi is the inside enthalpy. QSR and QLR. This is QLR. Here it is mentioned only QLR. This is the room sensible heat load and the room latent heat load. QSR and QLR, room sensible heat load and room latent heat load. This is the total external loading. External loading means it will be due to sunlight, solar radiation. It will be due to infiltration of air and due to some other additional loads. This is a room solar sensible heat load and room latent heat load. Now, this is our cooling coil. So this cooling coil is responsible for the cooling and dehumidification of air inside this room. So what you are doing, we are taking some air from the outside. This is the air for ventilation. This air is used for providing fresh air into the room. So now it is entering and we are cooling and dehumidifying the air, and that air is going to the room with the help of the supply fan. And after some time, we know that after some time what happens, the conditions will change, the dry bulb temperature and humidity will vary. So continuously we have to do the air conditioning process. So one fan is supplying air to the room through the supply duct. The supply fan is supplying air to the room to the supply duct, and the return fan is continuously absorbing return air through the return duct, and a part of this air is exhausted to the surrounding, and the remaining portion is circulated through the cooling coil mixing with the ventilation air. So this M vent represents the amount of air, fresh air supplied. M vent is the amount of fresh air supplied. It is coming in contact with the cooling coil. Its temperature is reduced, its humidity and moisture level is reduced, and it is again supplied to the room. So this QSR and QLR are the external room sensible heating and room latent heating, and this is the QTC. This is the total cooling load in the cooling coil. So total sensible load on the cooling coil is obtained by summing up the total sensible load on the building and sensible load due to ventilation. So this and sensible load due to return air duct and fan. I will explain. So QSC, what is QSC? Total sensible load on the coil. Total sensible load on the coil is known as QSC. It is equal to total sensible load on the building. This is R means room sensible heat plus sensible heat due to ventilation, additional air that we are supplied for ventilation purpose, and QS sensible heat gain in the return duct. So I will explain this equation with the help of this figure. So total sensible, this QSC, total sensible heat load in the cooling coil is the sum of the cooling load, sensible cooling load in the room, plus we are supplying some amount of fresh air. The temperature of that fresh air has to be removed or reduced. That load is QS vent, the amount of energy absorbed for reducing the dry bulb temperature of ventilation air. That is QS vent. QSR is the cooling load in the room. This is the amount of energy absorbed for reducing the temperature of air coming from the outside. And third one, QS return duct. What is that QS return duct? We know that air is continuously absorbed using this return fan through this return duct. So the same return duct, this air is coming and mixing with the ventilation air and going to the cooling coil. So when the air is flowing through the return duct, there is a chance that heat transfer takes place from the surrounding to the air inside the return duct. When the air is flowing through the return duct, air will absorb heat from the surroundings. There is a chance of heat leakage from the surrounding to the air inside the return duct. So that heat has to be removed. Also, when a return fan is operating with the help of an electric motor, there is also some slight heat leakage. So this heat has to be removed. That heat is known as QS return duct, sensible heat load due to return air duct and fan. So the total sensible load on the cooling coil is due to sensible load on the room plus sensible load due to ventilation air plus sensible load due to heat transfer in the return duct. Similarly, we can calculate the latent heat load. Similarly, the total latent load on the coil is obtained by summing up the total latent load on the building, latent load due to ventilation, and latent load due to return air duct and fan. It is QLC. Total latent heat load on the cooling coil is equal to latent heat load in the room plus latent heat load due to ventilation air and latent heat in the returned duct. There will be some latent heat load in the room, that is room latent heat load QLR, plus some fresh air is supplying from the surrounding atmosphere. So we have to remove the moisture content of that atmospheric air. We have to reduce the moisture content, so that will cause latent heat load due to ventilation. So room sense latent heat plus latent heat due to ventilating air plus latent heat load in the return duct. So if there is a leakage of atmospheric air into this return duct, that will cause some latent heat loads. So that is a QLC. Finally, the total cooling capacity of the system will be equal to total cooling capacity of the cooling coil is equal to total sensible load on the cooling coil plus total latent load on the cooling coil. Total cooling capacity, required cooling capacity of this cooling coil. So we are designing the required cooling capacity of the cooling coil using QTC equal to QSC. The total sensible load on the cooling coil plus total latent load on the cooling coil. So this is a figure that we had already discussed. This is the total sensible cooling load on the cooling coil. This is the total latent cooling load on the cooling coil, and this is the total cooling capacity required. Thank you.